what is the frequency of the signal that's displayed here? So we're always trying to visualize an entire waveform. And if I look at the crest here, then I can count over 1, 2, 3, 4 divisions to get from crest to crest. I can also kind of see that the wave kind of like starts here, dipping down, and an entire waveform from there to there. And that's also 1, 2, 3, 4 divisions. So I know 4 divisions per wave, just like the example on the chalkboard. I'm going to start with the time-based setting. 5, I'm just going to convert it here, nanoseconds per division. So a nanosecond is a billionth of a second. So that's the same thing as nano. So there's that many seconds in each one of these divisions. And I know that there are 4 divisions per wave on this oscilloscope. Every 4 divisions is 1 wave. So by multiplying these 2 factors, I'm canceling out divisions, and I'm in seconds per wave. That's called the period of the wave, the time period of the wave. So that's our first calculation there. 5 by 10 to the negative 9, so 5 billionths times 4, that's 20 billionths. So that's 2 by 10 to the negative, what? 1, 2, 3, 8. 2 by 10 to the negative 8 seconds is the time period of this wave. While that number is still in my calculator, I can just take the inverse of it. So remember, 1 over the period is the frequency. And so I'll just use the handy inverse key. I can show you that. All right, and so if you look right here, I got that 1 over x. Okay, maybe you can't see that. It's kind of fuzzy. But try to find that either x to the negative 1 or 1 over x key. So when I hit that second there, so that's the inverse of that number. And that looks like 5, let's see, 50 million. 5 by 10 to the 7 hertz. Okay, so choice C is correct. And that's how those calculations go. Let's look at a couple more. I think this is an entire waves quiz here. You can see like there's a cathode ray oscilloscope question or 2 on there. This is what I was talking about. You know, take care, because look here, they're showing you 1 centimeter, but look, they give you the time-based setting in microseconds per millimeter. So that's the kind of tricky thing where they're trying to give you a little bit tougher of a problem with this. Let's do question 9 to see, you know, kind of what that's going to look like. Question 10 looks pretty cool down there too, right? Pretty cool. Question 9 here. It says, a cathode ray oscilloscope, CRO, is used to display the trace from a sound wave. The time base is set at 5 microseconds per millimeter. So if you just sort of stick with the words, you know, then you can't go wrong. You know, write down what you're given, look at what's given here, and kind of just write it all out. So 1 wave is occupying, oh, like from here, that's like 1, 2, 3, right? So like from here goes to there, that's like 1, 2, 3. Okay, well, from this crest to that crest, there's 3 centimeters. So if I write 3 centimeters per wave, that's what's on sort of this display. There's 3 centimeters per wave. But the time base is set at 5 microseconds, okay, per millimeter. So these aren't going to cancel out if I were to multiply them, right? Centimeters and millimeters won't cancel. So I either need to convert this to millimeters or this to centimeters. Probably easier to just convert 3 centimeters. Well, that's going to be 30 millimeters. So if there's 3 centimeters per wave, that's the same thing as each one of these is 10 millimeters, right? If this is 1 centimeter, that's 10 millimeters. So 10, 20, 30 millimeters per wave. And that's what I mean by like just write the words down and let them sort of take care of the calculation for you. When you multiply these now, you'll have seconds per wave, which will be the time period, which you can then take the inverse of. So 5 by 10 to the -6 times 30 millimeters per wave gives me this number in my calculator that I don't really care about, but it is the time of the wave. So if I take the inverse of it, then I get 6,666.7, which rounds pretty neatly to 6.7 kilohertz. Okay, so kilohertz, right? Thousands of hertz. This is in the thousands place. And so the last step would be maybe converting it into kilohertz if you couldn't sort of translate that to this. It's certainly not 67,000. It's